Hi, my name is Xiaolin Chen.
And I'm Dan Benoit. Welcome to this installment of our video blog, Casual is the New Formal.
A question we often get asked is, where do I get properties for formal? In this video, we will talk about techniques to develop properties for formal.
By far, the best way to get properties is to reuse properties that already exist. These come in three flavors. First are automated properties generated by tools. Second, there are low-level libraries of common properties that we can reuse. And third is standard protocol libraries. All the formal tools, including VC Formal, provide options to automatically create simple properties derived from the RTL. These properties can detect coding errors, such as array access out of bounds or arithmetic overflow. This won't cover very much of your specification, but they might find bugs that would otherwise require more effort to discover. So Xiaolin, what about using assertion libraries?
You definitely should. OVLs, for example, short for Open Verification Library, provide parameterized modules that can be instantiated into your design to check for basic behavior patterns. This can save the user from learning assertion language. If you're using standard bus protocols like AMBA and others, you'll probably be able to get a set of pre-packaged assertion IPs from the library. And this will not only check for protocol compliance of your device, it also will properly constrain the inputs coming into your design.
So those solutions are great, but they still won't cover all of the design functions that we need to check. What about using an assertion language?
SBAs, short for System Verilog Assertions, are the standard for customer assertion development. SBAs can represent a collection of signal behaviors in a very compact format. So this part of the System Verilog language is extremely powerful. Unfortunately, come with that power comes with complexity. So for most users, we would say do not try to write complex SVAs to start with, because it may be difficult to understand and difficult to debug. So stick with some basic things you know. Write RTL verification code that to simplify complex behavior before you apply SVA checker. In fact, you can write all your checkers in synthesizable code. Just use ways to check for correct behavior and assert never to check for error conditions, right? So some find this way is easier since they don't have to learn an assertion language, and it may be easier to control and debug. So speaking of debug, Dan, what advice do you have for assertion debug?
Well, assertions are intended to pass a certain set of legal behaviors and fail on any other patterns. So there are two types of coding errors for assertions. First, the assertion might fail on some pattern that should have passed. In this case, your formal tool might show a false failure. This might be aggravating, but at least it alerts you to a situation that requires debug. Another potential error is that the assertion passes on a pattern that should have failed. The assertion in this case might be proven, but some illegal behavior was not detected. This is a serious problem, and vigilance is required to avoid it.
That's right. One way to guard against false passing assertions is to insert some hypothetical bugs into the design and verify that the assertions would fail, right? If the assertion is complex, it might be even more necessary to create a small test bench to validate the behavior, right? Remember, your formal results are only valid if your assertions are accurate.
That's right. Now that we've covered the basics of assertion creation, we'll be ready to talk about analyzing assertion results in another installment of Casual is the New Formal.
Thanks for watching.